right. Okay. Yeah, it is working. Okay. This is kind of our last lecture, and that the one that we're going to have in December. December what? December 5th. We'll probably just go over a practice final exam and any last messages before the exam. What we're going to do today is our second of, say, 3 activities like this. We're going to get this chart up there, and I'm going to leave this up there for a bit, and then I'll go to an empty file and start over. But I've got a graph. It's a stacked bar graph. It's boys and girls. Now, for the sake of this experiment, I'm being oversimplistic with genders, and I'm giving them, stereotypical colors. So we're going to assume that boys and girls are the only 2 genders, and that and they're equally likely, which is not exactly true. So just so we don't have to be too complicated. And I'm also forcing this experiment to be a family with 3 children. So I've got a bar chart where you could see on the left, that's all boys because we have a label BBB. And then I've got 3 bar charts in a row where I've got 2 boys and 1 girl. Now, in my code, I'll call those things permutations, because a permutation on 3 things means that it could be ABC, ACB, BAC, BCA. There's going to be 6 combinations for any of the 3. So you could see that if I have 1 girl and 2 boys, I'm saying that the boy, boy, girl is going to be different than boy, girl, boy. I mean, maybe you don't think that's important, but if you're, the middle child, you feel like your place in the hierarchy, it might be important. So anyhow, we have a key up there with the boys and girls. We haven't had that before. And I want to show you here some sample output so that I could check that I'm doing okay at this point. I'm going to be running 1,000 simulations, and I can look at the 125, the 129, etc., and kind of just add those up real quick, see if they came out to be about 1,000. I'm not going to really do that, but it looks like it's going to be okay. Now, if I add these 2 numbers, I should get that one, and I do. And then for the boy, boy, girl, the boy bar should be twice as high as the girl bar. So if I look at these 2 numbers, do they add up to that number? That's a fairly easy check. And is this approximately half or twice as big? And the answer is yes. So that's going to be a visual check that I put up there. So before we get going on that, do you guys have any questions right now about anything in this week, next week, the final exam, so I could put your minds at ease, at least for now? I do have a couple notes up there that I want to talk about some things before we leave, but let's get this started. So I do want my dice class, so I'll go to my last file and I'll get that. Let me clear this out. Let me go to lecture 9, and I'll even grab the import. So if you have got code like this because you were with me or you followed along in the video, then go ahead and grab this. And I'll paste that. Now, let's see. If you didn't do this and you're using Thonny, this line right here is not going to work until you import, and I'm not going to go through that right now. So if that's you, which I doubt because had lots of people here last class, then you could always just go to CodeHS, and on CodeHS you don't have to put in that 1 line of code. Okay, so you saw some of the things that I'm going to put, and I'm going to comment as I go along. So we are going to put number of siblings. Now, if I do this, hang on, let me just. The intention of having I'll call it a constant, but it's a field, or a variable. The point of having a variable of number of siblings equals 3 is I want my program to be dynamic. Maybe I want to do something similar, but I want to have 4 or 5 or 6 children in the simulation. Now, you could tell from the graph that I had up there, and even some evidence left over, that I am kind of forcing this with my labels, because I literally will be typing out, I want my labels to be BBB, BBG, etc. There is a way to do that dynamically. It's a little bit above our pay grade for the day. So even though this is set so I could change it, the graphic isn't going to be able to change quite so easily. All right, and then I'll put in a constant for number of simulations. That absolutely is dynamic. That's easy enough to say I want to run a bunch or I want to run a few. Then we are going to put in a list that's going to represent the labels for X. You can go ahead and get ahead of me on that if you want. We're going to call it, not combinations. Combinations is a word that I've used for this in the past, but the one that I said earlier, permutations, where orders matter, those two words kind of go together in probability if you've done that before. So I'm going to say permutations. So my comment is we are going to initialize counts for each combination. Well, I'll get rid of that combination again. Permutation. Permutations is equal to, put the square brackets for a list. I'll go ahead and, put the end curly or square bracket, put my caps lock on, and I'm going to stop talking. One, 2, 3, 4, 5, 6, 7, 8. Looks like I got them all. Okay, you might be a little bit slow catching up. Oop, I see I got a missing end quote there. That's okay. You should be able for a while be able to look back up and see what I have. Make a dictionary to restore the results. We're going to do something very similar that we did last time. Is we'll make the dictionary and then we'll just scroll through, and we'll do, like, for every perm and permutations, we'll do that value, set it equal to 0. So whenever we say name of my dictionary, and then inside the square brackets, we put what is going to be an element and set it equal to 0, it'll say, well, I'll look for it. If it's not there, I'll set it equal to 0. If I look for it and it is there, then it might be 10. I'm going to set it equal to 0. So we're going to do stuff like that. All right, so I'm going to call my dictionary results. Results is equal to begin and end curly bracket, and then a loop for each perm in permutations. Results at perm is equal to 0. Now, this is not a method, so I'm not returning it. If I wanted to put all these things inside of methods, then I would consider returning. We could at this point do a print of results, and all I'm expecting is that I've got my keys and they're set equal to 0. So let's go print, and in parentheses, results. And here it's also going to check to see if my import's good, and it looks good. everything is set to 0, and I have 6 of them, and I have 3 versions with 2 boys. The girls are on different positions. I have 3 versions with 2 girls. The boys are on different positions. Yep, so everything looks good. Anybody having any problems at this point? Nope. Okay, then I'll keep going. All right, now we're going to simulate the random assignments. I notice that I don't have a die that I made. I could do that now, but it makes a little bit more sense to do it up here where the die class is. I'm not going to do it inside the die class, so I'm going to come up here before my comment of number of siblings, and make sure you tab all the way to the left. Otherwise, you're creating a die object in the die class. It will never get called. So I will call my die a coin because it's going to be a 2-sided die. So coin is equal to a die passing in 2. Since we passed in 2, that means that it's going to override num sides as 6. It'll set num sides is equal to 2. So a die called coin, we kind of talked about that last time. All right, so I commented out the print results. I'll probably never need that one again, so I'll go ahead and just erase that one. And we're going to simulate the random assignments. I'll take a little bit of a timeout. I mentioned this in an announcement. I mentioned it last class. But what you're going to do in your next lab is you're going to kind of go a little bit further than this. Now, it isn't just going to be you've got your notes from, or your program or whatever, from today and the previous class. It's going to be like a 5 or 6 page packet with instructions in it. And you're going to be on your own, and you will have access to the internet, but trust me, you can't just take the problem statement and put it into ChatGPT, because one of the biggest things that you're going to be dealing with is data. In fact, it's real data that I got off the internet, and so there's no way it could deal with it. Right now, it requires a human, and that's you. Okay, so what else did I want to say about that? Well, not much. Other than that is kind of my homework 10, but I'll still get back to it. Okay, so for x in range, num simulations, how many times I'm going to run this experiment? Okay, this is I was gonna say you could probably go to your last code if you have it available, the one we did last time, and take a look at it, but that's not exactly the case, because what we wanna do is we wanna flip a coin, and that coin is either gonna be a B or it's gonna be a G. But my coin doesn't report a B or a G, it reports a 0 or 1. That's easy enough, you do an if. Doesn't really matter which one you assign to 1 and which one you assign to not 1. But I'll go boys then girls. And what we're going to do is we're going to flip that number of siblings amount of times. So it does feel like right now that this could be dynamic, but I said that this data could be, but my graph isn't, because these are my labels. I could come up with a way to generate that, but maybe if I have time, we'll talk about that at the end. So what I want to do is I want to flip my coin. And if it's a 1, then I'll set it to B. Otherwise, I'll set it to G. And what I want to do is I want to have a word ready. And that word is this. You got to look at me. This word is this. It's just empty string. Okay? And then if I get that B and I want to put that in my word, I concatenate it. So word plus equals that B that I get. Otherwise, I concatenate a G. So I keep doing that 3 times. So maybe I get B, then G, then G. So that's what we're going to do in this loop. So we start off with my word is equal to empty string. And then a nested loop for J. Now I'm using X and J. I probably thought to myself, let's not use a Y because people might think it's a point. No, they're just throwaway variables. They're just going from 0 up to some number. 0 up to num simulations, 0 up to number of siblings. For J in num siblings. Now we're going to create a combination string or permutation string. if coin dot roll pren is equal to 1, then word plus equals B. And I had it in double quotes and erased it, but I could have kept it as double quotes. Now, it does feel a little bit weird to say coin dot roll, but I just named my die coin, right? I don't know if in this homework statement, which I haven't had, I don't have it completely finished yet, but I don't know if I am basically saying use the die class or not. So I don't know what to say about that. Yeah, go ahead. Did I mean to do what? No. I don't know where that came from. No idea where that came from. Oh, I see. That. I must have clicked somewhere, hit return, didn't look up. All right, thanks. Now I must have done that recently too, because I did do a run and I got a test. This that you see there, and it didn't crash. But I saw another hand up. Maybe you saw the same thing. Okay. All right. Else, then we're going to append a B or concatenate a B or a G. Else word plus equals G. All right, now I'm at the level of else. I don't want to be here because what I want to type, and I'll go ahead and type it, but realize I want to be back a little bit. I'm going to untab this. So results at word plus equals 1. So if I do this, and this is an accident, if I do this and it's not tabbed back to the 4, then what it's going to do is it's going to make a key B, it's going to make a key G, because every single time it's going to try to take results at word. I want to wait until I've got all 3 letters in the word, and then I want to do results at word. Having already gotten all of these keys ready, I should only be getting one of these 8 keys. And then whichever one I get, it'll go from 0 to 1 or from X to X plus 1, whatever it is at the current time. And that's it for simulate our random assignments. So now that I have that, I want to print results. And so now I should see exactly this, except for those zeros should be replaced with numbers that look kind of like I had up there before, numbers like 125 to 170 or so. So let's run this, and I got an error. What line? 38. What did it say? Oh, I want that to be in range, just like it is in 36. All right, so we're going to put range in here and put num siblings in parentheses because that'll be my number. So it'll go 0, 1, 2, 3. Let's try again. Okay, so yep, those numbers look pretty good. So I think that's okay. I'll keep that because as you saw, even once I got that graphic up, I want these numbers available so I can kind of look at the graphic and go, yes, my graphic is coming out all right. All right, so now I need 2 more lists, and they're going to be for the height that is blue and the height that is pink. So those are going to be boy heights and girl heights. Boy underscore heights is equal to just an empty list, but I'm going to put comments here. All boys, 2/3 boys, think I'll go, yeah, I'll go plural every time. Do it again, 2/3 boys, comma, 2/3 boys. This is mostly for you. Then it's going to be 1/3. And that's just the order that I'm going to see these things, and I could just look down here in my output in the shell. You can see why it's all boys, because there's no girls. You can see it's why it's 2/3 boys, because it's boy, boy, girl. You can see it's why it's 2/3 boys, because it's boy, girl, boy. So this is just something that I could look at when I have my graph up there and get that everything's good. I can copy this. Just be aware that, you know, a few things change. So we're going to call this girl heights. I see an error right here. This should be an underscore. It's no good with the dash. I didn't notice it until after I pasted, but there we go. Girl heights. Now this will be no girls. Then 1/3, 1/3, 1/3, 2, 2, 2, and change no to all. And now I will copy girls, paste over boys. Again, this is mostly for you. You probably get it because you saw it before we even started class. But in this program, I do have a lot of comments so that later you can take a look at it and it's going to be much easier for you to read while you're trying your own work. All right, now, what should I call this? I didn't put any labels in my notes. So what we're going to do is we're going to go through our dictionary after we've populated it, and you can see an example that's down there. And what I want to do is I want to get out of it the number of boys and the number of girls. Now, right now, I think the only thing in my program that isn't dynamic is that the number of children is 3 is hard-coded this way. So this line right here, it's a little, it doesn't feel that good to me because I always want my programs to be dynamic, but I said, you know, I could talk about that a little bit later. But what you're going to see for the code that I have down here, I won't just go 3, 2, 2, 2, 1, 1, etc. I will show you how to make this a dynamic way to tear out the number of B's or the number of G's. All right, so for the key and value in results dot items. So remember, there are 3 ways to iterate through a dictionary. So you can iterate over the keys, you can iterate over the items, or you can iterate over the values. If you iterate over the items, then you get like an enumerated, well, it's kind of like an enumerated version where you have the key as your first argument and your value as your second. All right, blue height is equal to key dot count inside the parentheses a B. I'm going to put a little pound sign there so I remember that I'm not done with that line. But, all right, so it's going to go through all the items. The items are going to be BBB 146, BBG 117, or some other different version with a different experiment. But we're going to take a look at the key, and we're going to count the number of B's. That could be 3 or 2 or 1 or 0, and you could see that up here. I guess you don't see a 0 because I put no instead of 0. I didn't put a 3, I put all, but you can easily get, through a little bit of logic, that it's going to be 0, 1, 2, or 3 when it does that. Now, count. If you used count before, I'm not sure if you did it with strings. You may have in one of your labs or a homework assignment. What you may have used count for was maybe you have a list and you want to see how many times something appears in that list. But anything that is is a structure like that, like anything that I could sequence through, iterate over, then I might be able to use the count for it. And I can use count for string. It's going to find how many characters or substrings, right? Like if I had BB, then BB might count, 2 for BBB, because we count 1 and 2, and it count 2 and 3, or 0, 1, 1 and 2. That's probably not clear. Anyhow, that's what we got so far. But that doesn't give me the height. That just gives me the multiplier for the height. So if I get 3, then what I'm going to do is I'll divide by the number of children. Again, it's dynamic, because if I have 4 children, then I'd be dividing by 4. And then we're going to multiply by the value. Okay, so taking a look at this right here, what it would do when it hits this is it would find there's 3 B's. So we would have 3 divided by 3. That gives me 1. And then I'm going to multiply by 146. That'll give me a height of 146 if it hits this. Now for this guy right here, it's going to get 117. Okay, it is divisible by 3. So it'll count the number of B's. It'll find that there are 2 of them. So it will have a multiplier of 2 divided by 3. So I'll have 2/3 of the value. So I'll have 2/3 of the 117. And so you did see me run this ahead of time, and you often had like 1/3 and 2/3 that you might have to add together. Yep.
Isn't it non-siblings and not children?
Could be. And it might be siblings in my notes, and I just put in children. So it's children here. And what did I call it up here? Siblings. Okay, yeah, let's stick with the siblings. That's the first time I made that mistake, I think, or you might have caught it before. You don't know? Just caught it this time? All right, well, I would find these errors if I run them, but she caught a different name. And I might have to do that again because, up top I have, I think, children. All right, and I can copy this and do the same sort of thing for the pink height. But we look at G's instead of B's. Okay, now we have these empty lists here, and we're going to go through all of the keys, and so there's going to be 8 keys, and so we are going to get like a boy version and a girl version of that key. So if it looks at, say, let's go to this one, BBG, then it will store at index 1 something like 117 times 2/3 here, but I'll do 117 times 1/3 there. So we need to now append that to our boy heights and our girl heights. Boy underscore heights is equal to, or dot append, and then blue height. Do the same for girls. So I'll copy this, paste it. Girl heights, append this to pink height. And I have a misspelling in here. And I misspelled height up here. So let's fix it here. And I should test this now. And anytime I made any misspellings, then I should be able to find it out because I'll get kicked out with an error. So let's print boy heights. And let's print girl heights. And now if everything's working, we should have everything but the graphic for when I ran this at the beginning of class. It didn't crash, and I could see I've got 110. If I had 0 and 110, I get 110. I take a look at the 132, I add the 44 and the 88, and I get 132, and the 88 is twice as big. Just a quick check here. Still twice as big, still twice as big, now half as big, half as big, half as big. It looks okay at a glance. So I feel like my experiment's getting the right data. Any other issues at this point? Okay, now we get the graphic. So we're going to create a bar chart. It has just a little bit more things to keep track of. We've got this legend that I put up there that we didn't have before, but mostly this is going to look like the graphics that we made before, where you're going to have to put the X labels, the Y labels, and the title. I think I put that as comments in my lesson from last week. So make sure you do that whenever you do your assignment next week. But I also will probably deal with ticks this time, or X ticks this time. I absolutely did not have to do that last time, and I showed you that I didn't, because the computer would have come up with the very same tick marks that I would have come up with. But here it's probably going to come up with 1, 2, 3, 4, 5, 6, 7, 8, and I want to force it to be BBB, BBG, etc. So last class that wasn't important. This class it will be. So label for the X and the Y, the title, put those always. Ticks, maybe. Legend, you may have to have a legend in the final bit of your homework, so I think it might all be relevant. All right, so we're going to create the bar chart. Bar width is equal to 0.5. You can guess what that's for. Indices is equal to range len of permutations. So that should set it to right now 0, 1, 2, 3, 4, etc. Because I have 8 different permutations in here. But we'll set the ticks to literally BBB, etc. We can just get it from here. Do I do that dynamically? Let me see. I think I do. All right, anyhow. The next line that I have here is a little bit strange. There are some things there where I don't have to use subplots, but there are some where I do. So it's a different library, what's built in. Everything I did last time, I think, did I even do a line chart last time? I think I did. I think I did, and I just took it out, right? And that was just like plt.plot and in parentheses x comma y, where x and y were lists. So even though we're starting with a dictionary, we need a list. So maybe last time we made a dictionary, and from that dictionary pulled it apart and made lists. I may have done it the opposite way when I first did it. Here we kind of already have our list because we needed them for the heights. But I think because this is a stacked bar graph, the PLT just straight up can't do that. So I need this in order to get this to work. I've looked this up before, but to be honest with you, I did not today. So maybe I will put that in as an explanation in the homework so it's a little bit more clear, because I know I'm not being right now. All right, so we're going to add the bars for the boys. Bars underscore boys is equal to AX, that's the name of the subplot, and this is the name of the figure. Now, I don't think that I could change what these two things are. Typically in Python, whenever I have a comma and I'm setting it equal to something, I have two things on the other side. So the first thing would go to fig and the next thing would go to AX. So there's something going on here, which again I've looked up before but haven't today, where this may be returning, say, maybe it's returning a tuple, and from that tuple, a tuple with two things, it could tear out the figure and the AX from that. All right, so bars underscore boy is equal to AX dot bar. This would be kind of like PLT dot, what did we use besides line last time? It was just bar, right? Line and bar. So AX dot bar. And as arguments, indices, that's going to give me X right here. For Y, boy heights, an argument we didn't have before, bar width. Next argument, color is equal to, in quotes, blue. Here's something else I probably mentioned last time. I've looked this up before. It's not going to know like the millions, or I don't know how many colors there are. Lots, many, many, many colors. And in our vocabulary, many are names, some of which you've probably never even heard of. They're not all going to be in this library. You could probably run what colors are available and see what you'd have there. And label. The label is going to be for our legend. Label is equal to boys. I got very little to change, so I will grab both these two lines and we'll do the girls. Change the name from bars boys to bars girls. It is still AX.bar. It is still indices. We'll change boy heights to girl heights. Bar width is still there. We'll change the color to pink. That'll show up, both the blue and the pink will show up in the legend as well as be the colors of the bars. We'll change the label from boys to girls. I'm going to leave myself a note here that there is something missing, but you wouldn't necessarily think that at first because it was a copy and paste and it looks like it changed all of the relevant things, but we'll wait until I can actually run it before I'll show you, hey, look what's missing. I actually did this code, I don't know, Tuesday, Wednesday, I don't remember when. It wasn't yesterday, it wasn't today. And I thought it was fine. I came back to it today and I'm like, ooh, my data looks a little bit fishy. And then I realized what was missing. So I'm going to kind of make the same mistake that I did in real time. All right, so now our labeling. Our labeling is the stuff where we put in the X labels and the Y labels and the title, etc. AX.set underscore X label. So I believe this is a little bit different. When we weren't using this line 63 with a subplot, we were doing something like X label, not AX.set underscore X label. Inside the parentheses, this is similar. We'll call it sibling combinations. I'll call it sibling permutations. I'll copy this to do my Y label, change that. And the height is, I'm just going to label this count. AX.set underscore title. In the parentheses, sim distribution of boys and girls. I don't know if this title is too long. I don't know what I had up there when I came in. So we'll see. If it's too long, I'll shorten it. This also feels hard-coded, but if I change the number of children, I can easily change that or just take it out. Let's see, ax dot set ticks to indices. Ax dot set underscore x tick labels in parentheses permutations. Now, it does feel a little bit weird to me that L's not capitalized, that L's not capitalized, that T isn't, that L isn't. In Python, you tend to put an underscore there. In other programming languages, you tend to put a capital letter there. But these are built-in functions for PyPlot. So I have to live with it. And then we're going to put in a legend, ax.legend. I don't need any arguments because I already have the stuff I need right up here for that legend. And then one more thing, plt.show. Well, let's see if it works. Nope. Permutations not defined. What line? 61. Permutations. Misspelled. I'll try again. Where's this one? Line 63. plt.subplots. This is a function and needed parentheses. So line 63 needs parentheses. Try again. All right, looked like it worked and then it crashed. So this might have something to do with the graphics. Line 69. What? 1, 2, 3. Did I forget a parenthesis? Comment at the end. What's up? Girl Heights. Did I misspell it elsewhere? H-E-I-G-H-T-S. Oh, thank you. Missed that. Appreciate it. Let's try again. Okay. Axis, not set ticks. You spell it. This is line 75. Set. Okay. This has to be an X ticks because you have an X ticks and a Y ticks. I've made that mistake before. Let's put an X in front of X ticks. Oh my. 77. Yeah, misspelled legend. I'm rocking. And we're live. Okay. So here, the first thing I noticed was, I've got more extreme cases than I thought, like all boys and all girls. And then I looked down at the data. Let's get rid of this so the data will go all the way across. And didn't mean to stop it, but look, it happens again where the boys and the girls, all boys and all girls are the tallest. And if I check my data, that doesn't keep happening. Word execution interrupted. Yeah, okay. Oh, here's one where it's almost as high. Okay, so that's the first thing I noticed. You notice anything else about this? What do you notice? Yeah, there's no blue in here. And so, I actually noticed that third. What I noticed here was those guys look like they're the same height. And they were supposed to be like 1/3, 2/3. I was never supposed to get like a 50-50. And so it took me seeing like all three of those things before I realized what the problem was. So the one thing that's missing here is the actual stacking. So what's happening is that the pink is just getting pasted right over top of the blue. That's why they look like they are equal heights for the first set of thirds. and like it's all pink for the second set of thirds because the pink should definitely overwrite the blue. So we need another argument in here, and since it is named, it could go anywhere in here, but I happen to have it right here. So I'll put a comma there, and in between these two commas, bottom is equal to boy heights. And if we run this, it looks like we're good. Okay, so I've got 5 minutes left. I had a couple of students email me and say, can I get homework 1010 open? I wondered if my announcement was not clear. Homework 1010, I said I'm going to replace that like on day one. I don't think I will call it homework 1010, and no, it's absolutely not ready yet. You're not doing that on your own. It's this assignment that you're doing in your lab the week we come back from break, okay? And currently I'm calling it homework 10, but it doesn't really feel like a homework. It's more like a lab practical. And here's what's going to happen in there. I'm going to give you data on Husky CT to download. I actually made this last year, and I really did feel like we were getting a lot of rain, and it seemed like and this was like January through March, and if we were getting that much rain, but if it was snow, it would have turned out to be like 17 feet of snow or something like that, right? So it just seemed like we were getting a lot, and way more than I thought. So when I went to go make an assignment to replace 1010, because COVID data is kind of depressing after we've been so long past it. And by the way, the actual assignment doesn't even work anymore, which I figured would happen after a while, right? It's just like that repository is not accessible, so we can't even get the data for 1010. At least I think that's how it's working. So anyhow, you're going to get these two files, and you're going to play with it as I step you through the lab. Try to process it as you play with it step by step, because one of the things you need to learn from it is that real data is challenging to work with. The people in stores are responsible for putting in stores data, or somebody around here, and the people in Seattle are responsible for putting in Seattle data. And nobody says, we are the official Weather Bureau of the United States, and you must enter your data like this. And so they don't add the data in the same columns. They don't add the data with the same headers. They don't add the data the same way all the time. Sometimes if it is 0, they put nothing, because it's easier to put nothing, right? And so you're going to have to deal with that kind of data. I'll tell you that Seattle data is a little bit more mainstream because maybe it's a bigger city, right? And stores is probably the one that's going to give you fits. So play with it in the order I give it to you. One of the big deals is trying to figure out how to get real data to actually function for you. So that's this. Now, homework 11. Homework 11, I started working on. I'm not even nearly close to finishing it. But what I think is that it is going to be an optional assignment due on the last Friday the 5th. And it will replace something. Like if you have a 0 for a homework, then it will replace that. So not everybody has to do it. But if you, even if you have like a very bad homework, like you were nailing everything, but homework 7 was a 20 out of 37 or something, then feel free to do this optional assignment. I already did talk about the last lab. I don't really have any way for you to make up homework 10. So if you missed that lab, you are basically going to want to do homework 11 to replace homework 10. And CodeHS over Thonny. Okay, now because I am using data files, if you are using Thonny and you're using it on the cloud, then you might lose the data files, which means you either got to figure that out or you need to go to CodeHS, because CodeHS is just ready to accept those files. Okay, so what I'm doing, what I'm instructing the TAs to do is just say, I know that the majority of people are now using Thonny instead of CodeHS, but I'm guaranteed that this is going to work for CodeHS, and I've written it to work for CodeHS. So if you haven't opened up CodeHS before, just go. You don't have to go to any class. You just, have an account and you say, I'm going to the sandbox. Doesn't cost you anything. Okay, you just make a sandbox and you're going to end up submitting the file. I don't know how yet. Okay, so that information is still coming. All right, that's all I got for you. Do you have questions on any of that or anything that I haven't mentioned? Okay, good luck wrapping up the course. Have a good weekend. Have a good holiday.